Hello everyone and welcome to this video. Today we are going to deep dive into tokenization, which is a very crucial part of NLP. Tokenization is a process where we break down a longer sentence into smaller pieces. Let's take one example. We have one sentence, I am Ravi and I like ML. And we splitted this sentence using spaces. Then we will have I am Ravi and so on. All this element is nothing but a token. So these elements, small elements which we created from this longer sentence is called token. We can have different kind of token. This we call word level tokenization. We have sub word level tokenization as well as character level tokenization. In word level tokenization, as we have seen, we convert a sentence into word level. Like uh, when I'm saying a word level, it doesn't mean it necessarily be a single word, but it can contain also a smaller sentences. uh, if we use comma as a delimiter, then we will have I am Ravi and I like ML as a token. But problem with word level tokenization is like as we have taken example, if we use comma, then we have token I am Ravi and I like ML. But if I give only Ravi, then we can see that if we use comma as a separated to make tokens, then this Ravi will not get any token because we don't have only Ravi in our token. And at that time, this Ravi will get converted to some other token called unknown token. Unknown token is you can think like if we don't get a word which is present in our vocabulary, then those words get a unique tokens called unknown token. So it is very important to choose a delimiter to generate token, because if we use anything, then we may get out of vocabulary kind of situation. One other method to not get out of vocabulary like scenario is to use sub-word level tokenization. What is this sub-word level tokenization? So in sub-word level tokenization, instead of only converting a sentence to a word or to a piece which is already present in sentence, we also use which is present in the sentence but not directly. What I want to say, like if we convert this I am Ravi, let's say we have one sentence I am Ravi, then by using sub-word level tokenization, we will get output something like I am RAV and RAVI. So as you can see, in sub-word level, it is not only converting this sentence into a word, but which is present in our sentence, but it is also converting it to some smaller words by or smaller sub-words. Is better to say, like because Ravi is a word, then RAV is a sub-word. So what's the benefit of using this? If we go again like I am Ravi and I like ML, if we get Ravi, then there is a huge chance to get Ravi in our corpus also, because in subword level it can divide this sentence into I am Ravi as well. And by using subword level, as we can see, like we can avoid out of vocabulary kind of scenario. Apart from subword level and word level, one more type of tokenizer we have, and that is called character level tokenizer. In character level tokenizer, it will learn to tokenize this sentence in characters, like if we give this sentence to character level tokenizer, then we will have only a character, unique characters, like I, A, M, R. We all is was already sorry, A we already taken, so we will not take A again. V, I, and so on. So in character level tokenization, we will have tokens like something like this. So one may think that it is better to use character level tokenization all the time, but and we can get high accuracy, but it is not the truth, because if we use character level tokenizer, then we won't get any meaning of the words that is present. All the times whatever tokens we will have in character level, it won't convey any meaning, but in word level, whatever tokens we will have, there will be high probability of some meaning to that token. And if we have a meaning to our token, then it will be easy to learn our model about context of those words. So it is not always recommended to use character level or sub word level or word level. Character level base, most of the time we don't use, only word level and sub word level most of the people use. But yeah, again it's depend upon you, like what you want to use. Either you can use word level or sub word level. uh, let's continue with word level only. So once we convert this sentence into small words or small pieces, our we generated one token, but we cannot take directly this token for further processing, because for processing we need numeric kind of data, right? To convert this token into numeric, what we use, like we use one corpus. At the time of training of tokenizer, whatever sentence we had, we saved in one corpus, which we later called as a vocabulary, right? So in that vocabulary file, we will have each token along with some unique IDs, and we will replace all the tokens with corresponding unique ID at the end of the tokenizer. For example, these tokens at the end of complete tokenizer, we will have one list with something like 23, maybe 27, or we maybe 195. And this is all about the theoretical knowledge. Let's implement this into PyTorch. Before diving into the implementation part, let's understand the flow of overall program. So for the tokenizer, we need to first pre-process all the text. Then we need to select appropriate model, like if we want to use word level tokenizer or subword level or character level. Once we selected the model, the choice of model we want to use, we need to select appropriate trainer also. So we will select appropriate trainer script. Like if we are using word level training model, then we need a word level trainer as well. Apart from this, we also need the splitting. Like as we already discussed in this video, we need something to split, right? If we want to split based on space, or we want to split based on comma or any other delimiter, so we need at least these four things in our tokenizer. And then apart from this, just we need data or sentences. So let's define a function build tokenizer, but before this we need to import this. We are importing for processing. Then we need model, then we need trainer, word level trainer, and one more thing, like based on which we want to split so we are going to split based on space. So once we imported everything, now we just need to write our script. So we need data set as input, because on this data set we will take, from this data set take we will take sentence, and then we will convert all the sentence into tokens. Okay, so let's write and we want word level. Not white space split, we need white space. Then we need to import trainer, in word level trainer, when we define trainer, at that time also we are going to pass some special tokens which we will need at the time of conversion of tokens. So we just need, so basically we want one unknown token if we get out of vocabulary, because you have to understand, like whenever we have some data set, we just have one sentence, we don't have this unknown and start of sentence token. These tokens we have to import by ourselves into our tokenizer corpus, so it can understand when a sentence is starting and when it is stopping. From iterator, now we will pass our data set and the trainer we want to use. Yeah, that's it. So basically we have build our training tokenization pipeline, and we just need to return it. So to understand it, let's take one example. So now we have one data set or a list of sentences for which we want to train our tokenizer. So basically after training this tokenizer module, we will have corpus in a word, because we are doing word level, we will have corpus which will contain words like I am Ravi, Kumar, what, your name, like this. So let's train our tokenizer. We will pass, and this will convert our sentence into tokens, as well as it will train one tokenizer model based on white space as well as word level. Like it will split this sentence with respect to space. Now once we converted our sentence into tokenizer, let's check what is the tokens what are the tokens we have generated and what are the corresponding ID. And for that, let make one temp dict, or we will say corpus instead. Where we will save our this. So for token and token ID in tokenizer dot get vocab size, get vocab dot items. So tokenizer dot get vocab basically will give us all the vocabulary we have saved or we have created during the tokenizer process, and it will return as an items. So we will have token and token ID. So let's append corpus dict token id, and we will assign key as token. And then let's print this corpus dict. Now in this dictionary you can see like overall sentence, this sentence is converted to token where do is one token, and with token id 7, then unknown is given token id 1, sos is, sorry, unknown is 0, sos is 1, your is 15, Kumar Ravi word. All the words here got one separate token, and here you can see like I, here I is capital. So one thing to remember guys, when we create our tokenizer, it is very necessary to know that if you want your sentence as a cap, I mean sentence as a case sensitive or not. If you don't want, then here in word level only you can specify if you want to convert all the sentence into lower case or not. So these things we can do, but most of the time I'll say like it is better to take case sensitive, because then it can differentiate with respect to name. Even though like you can create your sentence lowercase sensitive, like, and then just give name or places as an exception, like you have to mention those places and or names or words whatever you want in capital letter, but uh, it is not recommended, and I'll say like we should use this case sensitive. So apart from this tokenizer dot get vocab, we can also access our tokens using encode method. Like it's my mistake. We can see that all the tokens I am Ravi Kumar got converted to tokens, and in the same way if we want ID we can also also generate IDs of the corresponding token. Like I has a token number 4, M is token number 6, Ravi's ID is 11, and Kumar's ID is 8. So that's it from my side, and thank you very much for your attention.